Our next presenter is Benedicta Nashiff from Pharmaceutical Sciences.
So cancer is a very common disease and it's one of the leading causes of death worldwide. Many of us has been touched by this disease somewhere, one way or the other, either through a friend, a neighbor, a colleague, or even ourselves. In cancer therapy, we often think the problem is the cancer cells. If we can get rid of these cancer cells, we should be able to cure this disease very easily, right? But sometimes the problem is not the cancer cells. The problem is its environment. Think of a scenario where we have a kingdom that has a strong walls around it. Inside this kingdom is cancer cells. Outside the kingdom is chemotherapy drugs. Now, the use of chemotherapy drugs is a very common treatment in cancer therapy. If the walls are very strong, then chemotherapy drugs would find it very difficult to enter these walls. Cancer cells will live happily, grow, and the disease will become very deadly. Cancer occurs as a result of uncontrollable cell growth. So if the number of the cells keep on increasing, then the disease becomes very deadly and difficult to treat. This scenario is what happens in aggressive tumors like triple-negative breast cancer, which is the main focus of my research. So in my lab, what we want to do is to make these walls soft so chemotherapy drugs can work better. We know there is a particular enzyme in the body called LOX enzyme. This enzyme is responsible for making the walls thick. So we have created a drug. Our drug can bind to this enzyme and stop the enzyme from working, making the walls soft so chemotherapy drugs work better. But then we would want to make our drug much more effective. So currently we are using computer modelings to understand how our drug would bind to this enzyme and if our drug would bind only to this enzyme. Since there are so many enzymes in our body and we don't want our drug to bind to any other random enzyme that can bring side effects. Overall, we would want to combine our drugs with chemotherapy drugs so that together both can work smart. Our drug would go in first and break the walls, then chemotherapy drugs can then barge into the walls and kill the cancer cells. We want to make existing treatment in cancer therapy effective again so that hard to treat tumors like triple-negative breast cancer can be curable. Thank you.